Hi everyone, I'm Mike Poland, the scientist in charge at the Yellowstone Volcano Observatory, and I'm here on a gorgeous day in Yellowstone National Park to bring the September 2019 activity update. Before we get into what happened over the last month, I'd like to introduce you to one of our monitoring stations in the park. This is station P711. It's a GPS station. What we've got is the GPS antenna that's mounted on this very sturdy support here. It's sturdy because we want to look at very, very small changes in ground deformation over time, so it's got to be really, really stable. We also want it to be able to withstand some of the harsh environmental conditions here, like the heavy snow. All of these signals that are received by the antenna here from the satellites are sent over to the electronics box there where the power and the GPS receiver are, and from there it's radioed to a central receiving station and put on the internet for everyone to see. Now this particular station, P711, is located near Madison Junction. And that puts it in a pretty interesting location, actually. It's a few miles off to the west-southwest of Norris Junction, the Norris Geyser Basin, which, as many of you probably know, goes up and down over time. Now, from 2015 into late 2018, Norris had actually been moving up. But Madison's too far away to see that vertical deformation. But because GPS gets three-dimensional positions, not just up-down, but also north-south and east-west motion, we could actually see the Norris deformation here in a horizontal sense. So whenever Norris went up, whenever the area was inflating, this site here was actually moving to the west-southwest. And then whenever Norris was going down, when it was deflating, this site here reversed its motion and went to the east-northeast. So when you're looking at deformation, GPS is an outstanding way to go, and it's not just about the vertical, not just about up and down. The horizontal component of deformation is very important as well. And we've got over 24 GPS stations in and around the park, tracking how the ground is moving. And if you want to look at those data for yourself, there's many places you can go. There's, for example, the Yellowstone Volcano Observatory website and our monitoring page. You can also go to unavco.org. Now, UNAVCO is the group that has installed and maintained most of the GPS stations in the Yellowstone region. And finally, there's even the University of Nevada, Reno. Their geodetic laboratory processes as much GPS data in the world as they can get their hands on. So there's actually a huge wealth of information at these different kinds of sites. So you can go to those sites, check out the data for yourselves, and see how Yellowstone's deforming with GPS, the best way to look at ground motion in Yellowstone. Okay, well with that, let's talk about what happened over the last month in Yellowstone.
Let's start our review of the data with Steamboat Geyser, which had another record-setting month in August. It experienced water eruptions on August 12th, 20th, and 27th. The eruption on August 27th was the 33rd eruption of the year of 2019, which breaks the record of 32 that was set just last year. What you're looking at here is the temperature record from Steamboat Geyser. There is a thermometer that's in the outflow channel of the geyser. Now, when there aren't many eruptions, it records this normal up-down, which is basically just the temperature of the day itself, the air temperature. But as minor eruptions start to happen, we see more variability. And right before an eruption happens, we get a couple of days of lots and lots of minor eruptions, this sort of very wavy line right in here. And you don't see the daily temperature variations anymore because there's so many minor eruptions. This spike in temperature right there is the water eruption that occurred on August 27th, and immediately afterward the temperature drops down and we go back to these periods of just daily temperature variation when there aren't minor eruptions. And then the minor eruptions start to pick back up again as the geyser becomes more active. So Steamboat's continuing its pattern of lots of water eruptions. Where it stops, nobody knows yet for 2019, but certainly we've already broken the record of 2018. In terms of earthquakes, there were 128 earthquakes located in the Yellowstone National Park region by the University of Utah seismograph stations. The largest earthquake was a magnitude 3.5 located right here on the southern boundary of the park on August 15th. Also very interestingly, there was a swarm of earthquakes that occurred just south of West Thumb, Yellowstone Lake. Now, this swarm has at least 54 located earthquakes in it. Of course, there's many more, but they're too small to be located. But this is a nice little swarm that's occurring in an area where we've seen some swarm activity in the past. Overall, a fairly average month in terms of seismicity in Yellowstone. We haven't seen much in the way of changes in ground deformation. This is from the White Lake GPS station, which is on the Sour Creek Resurgent Dome. There hasn't been a whole lot of variation. This is the vertical motion over the last 2 years. The site had been subsiding with a little bit of ups and downs at an average rate of maybe couple inches a year or so. But over the summer, we haven't seen a whole lot of change. So there hasn't been much deformation to speak of on the Sour Creek Resurgent Dome over the last couple of months. The same is largely true of the Mallard Lake Resurgent Dome. This is the vertical deformation at the Mallard Lake Dome at a site that's near Old Faithful. There had been a slight amount of subsidence, this trend going downward, and then over the summer really hasn't been much in the way of change. Perhaps a little bit of up, but it's a bit early to say for sure on that. So we'll have to keep our eye on these deformation stations to see whether or not these changes persist or whether or not we revert back to the subsidence that had been occurring since 2015. And finally, there's a Norris Geyser Basin, which had been uplifting since 2015. It paused in about October of 2018, and since that time, there's really been very little change at Norris. So that's been going on now for about a year of no real changes at Norris. So overall, in the caldera, we haven't seen much in the way of deformation anywhere, either at Norris or in the caldera. So these trends of uplift at Norris and subsidence of the caldera appear to have paused, at least for the last few months. And then finally, I'd like to remind you that all of this information and more is available at the Yellowstone Volcano Observatory website. If you go to the link that directs you to Yellowstone Volcano itself, you can access our Caldera Chronicles, which is our weekly update. You can access the monthly update under the current alerts, and of course there's the monitoring map multimedia where you can actually look at the current fire that's burning near Brimstone Basin. This is a view of the Yellowstone Lake area from the Yellowstone Volcano Observatory webcam, and there's been a fire burning over in this area. We actually repositioned the camera so that we could see the fire more clearly, which helps the National Weather Service to predict fire conditions.
Well, that does it for the September update. Thanks a lot for tuning in, and we will catch you next month. Bye.